Hi class, welcome back. Today we want to study measurements. In order to study the properties of matter, certain measurements such as temperature, boiling point, freezing point need to be taken. And when these measurements are taken, they are expressed in standard quantities. And those standard quantities we call them units. So there are two common unit systems. The English system, that's what we use in the United States. It consists of miles and pounds and inches and gallons. But the metric system is used by the rest of the world. There you hear things like kilometers and kilograms and centimeters. However, the scientists use the standard unit, which is derived from the metric system. And they call it the SI units. So the standard units are derived from the metric system. Let's look at some of the examples of standard units. So there are several standard units used in science. For now, we'll focus on the standard units for quantities such as length, mass, time, and temperature. So these are some of the examples of standard units, but as I said, they are derived from the metric units. So we have what we call the prefix multiplier. These are prefix or words that are put in front of the basic units, which are the metric units, to change their meaning and change their value. For example, if the metric units have a value of 1, I'll give you some examples of metric units. But when we put kilo in front of any metric unit, we change its value. Because kilo means 1,000. Mega means 1,000,000. You can see them. Or 10 to the 3, 10 to the 6. Giga is 10 to the 9. Nano is 10 to the minus 9. Deci, please, you need to know these units and their values. So why do we use this prefix multiplier? So let's look at this. This is 10 meters. This is 0.1 meter. But look at this value. Look at this. It's so long. To call it is a little bit tedious. So it is easier to handle measurements of A and B. However, when the values become very large or very small, in such cases like C and D, respectively, it becomes challenging. That's where we need prefix multiplier. So prefix multiplier are used to express very large or very small quantities. That's why we use prefix multiplier. So for example, how do we express the distance 1 kilometer or 50 kilometers? This is 1 kilometer. You see, we write it like this. So 1 kilometer, kilo is 1,000. So this thing like this equals to this thing. So 1 kilometer is just 1,000 meters. Because meter is a metric unit and its value is 1. But kilo, its value is 1,000. So 1 kilometer equals to 1,000 meters. Or you can write it like this, 10 to the 3 meters. Or this is in words, or in their symbol, you can just write it like this. But you see, kilo equals to 1,000 equals to 10 to the 3. Then 50 kilometers. Is just 50 times 1,000 times meter, which is 5,000 meters. Fifty times 1,000 times meter. So yeah, it gives us 50,000. Sorry, 50,000. So that is why we use those prefix multiplier. So you can summarize it like this. I want to write only the symbols. So length, we are looking at the different standard units. Length, it is used to measure distance. The SI unit for length is meter. Note that the symbol of meter is M, lowercase m. But uppercase M does not represent the measurement of length now. Another common unit for measuring length is centimeter. You see, centi has a value of 0.01. So how did they get 100 centimeters? Divided by 0.01. Divided by 0.01. You see that this is 100. This is 1 meter equals to 100 centimeters. So that is how this is obtained. So that is how we get this. 1 meter equals to 100 centimeters. You do this arithmetic. And you see, it is also equals to 10 millimeters. So 10 millimeters, so 10 millimeters equals to 0.01 meters. So 10 times 0.001 meters equals to 0.01 meter. Yeah, so that's how this value is obtained. Let's see. This is millimeters. Milli. So this is milli. Yeah, this. Oh, let's leave the milli here. I just wanted to put the milli. Let's get this. So this is millimeters. equals to 0.01. So divide this by 10. Divide this by 10. So this is 1 millimeter will just be equals to 0.01 meters. So 0.001 meters. So this is what I wanted you to prove. So milli equals to 0.01. That's what I wanted to show. So divide this by 10, divide this by 10. You see that milli, this milli here, equals to 0.001 meters. So the value of milli equals to 0.001. That's the value. So try and solve these problems. We'll do some, I'll do some. Express the following in grams. So you see, gram is a metric unit. And we have 1 milligram. So this will just be 1 times 0.001 grams. And this will be equals to 0.001 grams. Because milli is 0.001. So let's look at this. This is 700 times 700 milligram. Milligram equals to 700 times 0.001 grams. So please take your calculator and let's do it. 700 times 0.0000. So this will give us 0.7 grams, you see. So 700 milligrams equals to 0.7 grams. Let's look at this one. 16.2 kilograms is just 16.2 times 1,000 grams. So 16.2 times 1,000. So this is equals to 12,162.00 grams. So that is how we express the following in grams. So you can see it there. Let me erase this so that you can see it. I'll just erase it. See how I calculated it. So that's it, and that's it. Now we want to take some example for mass. Let's talk about mass. Mass measures the amount of matter present in an object. Please, weight is different from mass. Weight measures the gravitational pull on an object, which depends on its mass. Weight can change, but mass does not change. The SI unit for mass is kilogram. So we have some other common relationships. So we have 1 kilogram equals to 2.2046 pounds. 1 pound equals to these grams. 1 kilogram equals to 1,000 grams because kilo is 1,000. 1 gram equals to 1,000 milligram because milli is 0.001. 10 to the minus 3. So these are some relationships. We want to look at time. Time, the unit, SI unit is seconds. We have other units like minutes, hours, and days, and weeks, and years. The 1 minute equals to 60 seconds, and 1 hour equals to 60 minutes. Now we talk about temperature. Temperature measures the average amount of kinetic energy. That is, temperature tells us how hot or how cold matter is. The SI unit for temperature is Kelvin, but we have other units like Celsius and Fahrenheit. How do we convert the temperature unit from one to other? So degrees Celsius to Fahrenheit, so this is degrees Celsius, equals to Fahrenheit minus 32 over 1.8. Kelvin to Celsius is the degree Celsius plus 273.15. So that is how we can convert Celsius to Fahrenheit and Celsius to Kelvin. So let's take an example. A sick child has a body temperature of 40 degrees Celsius. What is the child's temperature in Kelvin? So how do we solve it? We have this is 40 degrees Celsius. So this is 40 degrees Celsius. But we want it in Kelvin. We know that Kelvin equals to degrees Celsius plus 273.15. So all what you need to do is to add 40 here, and this is the temperature of the child in Kelvin. If we have to convert it to Fahrenheit, what do we do? So during one of the summer days in Gothenburg, a record temperature of 40 degrees Celsius was reported. What is the temperature in degree Fahrenheit? So we record what we have from the question. Then we choose, we want to convert it to degrees Celsius. So therefore, this is our equation. So what do we do? We want Fahrenheit. So we have to rearrange this equation. So we are going to convert it to degrees Celsius times 1.8 equals to degree Fahrenheit minus 32. So degrees Celsius times 1.8 plus 32 will give us degree Fahrenheit. So that's what we are going to do. So you have to know how to rearrange your equation to get what you want. So this is the equation we are going to use. So that's it. So that temperature of 40 degrees Celsius is 104 degrees Fahrenheit. So that is how we can convert the unit of temperature from one unit of measurement to the other. Now we want to look at some units which are being derived from other units. We'll call them deriving units. Deriving unit is a combination of other units. Example, we have volume and density. Volume is length times width times height. That's the volume. We measure the length, measure the width, measure the height. Then we multiply, we get the volume. That's why it's a derived unit. So, for example, the metric unit for volume is meters cube. Sorry, the SI unit for volume, not the metric. The metric is liters, but the SI unit is cubic meters. So as we said, the metric unit is liters, and we can also use milliliters. You know, milli is 10 to the minus 3. So milliliters is 10 to the minus 3 liters. So 1 liter equals 1000 milliliters. And 1000 milliliters is 1000 cubic centimeters. And 1 liter equals to 1.057 quarts. And 1 US gallon is 3.785 liters. The other deriving unit is density. Density is the mass of a substance divided by volume. It's a derived unit. See, we have mass and we have volume. The SI unit for mass is kilogram, and the SI unit for volume, the standard unit, is meters cube. So the unit for density is kilogram per meters cube. But we can use other units, grams per centimeter cubes or grams per milliliters cube. But note, 1 centimeter cube equals to 1 milliliters. So density, which is mass over volume, for equal volumes, the density of an object has larger mass. For equal masses, the density of an object has smaller volume. So heating an object generally causes it to expand. Therefore, the density changes with temperature. So density will change with temperature. So let's try and calculate density. Calculate the density of a 24.0 degrees centimeters cube wood that weighs 251 grams. So we know the volume and we know the gram. So we just need the density. Density is mass over volume. So that's the mass volume. But take no look at the unit. Grams per centimeter. You must put the unit. So we'll end the class at this point for measurements. We'll continue with measurements and significant figures next class. Thank you.